seen in the ATMs, okay, people, they come with armed people and a vehicle will come with a lot of cash and they want to fill it in the, these particular, that is, in the ATM, cash counters, etc. Now what you do is, if they are going for different locations, you can jam that signal, you can jam those position, which they are using the position for signaling, and you can anti-swoop them. That means you can anti-swooping is nothing but misleading the position. Okay, instead of showing you this location, it will show you another location. That is known as swooping. Okay, sometimes you are going for traveling for longer distances. You are completely billing on your GPS receiver, and they are going there. And imagine if there is some very important people are there, then what they do is they will spoof the signal and they will mislead the car to go to different location. That is known as swooping. How does the swooping works? Now, when I said that GPS receiver has to lock onto 4 satellite signals. In the swooping, what it will do is, this spoofer is nothing but an equipment which will transmit the GPS similar kind of signals, having much best signal strength when compared to the original GPS signals. Okay. Then what will happen is, out of 4 satellites, that GPS receiver, your receiver will lock onto only one signal from the satellite, whereas next 3 satellite signals will be taken up by this swooper. Swooper will automatically mislead your position. Instead of going to a particular location, you will be going to another location. So this is also used in the military application. You are launching a missile. The missile will calculate every particular position, hit the target. You use the best swooper, it will not hit the target. It will mislead the position. Okay. So this is used for the military application. It can also be used for civilian application. Now we are talking about GPS position. GPS position is based on signals. You jam the signal, you will not get your position. You sweep the signal, your position will get misleaded. So these are 2 challenging tasks. In the universities are also working on development of best anti-jamming technology, best jamming technology, best swooping technology, and best anti-swooping technology. So that is one area where a lot of work can be done. Now, in the modernized segment, they also want to improve the accuracy, availability of the signals, more coverage, more integrity, and more robustness, and also have multiple signals. We are having only L1 and L5 signals in GPS, but in modernized signals, they will have many number of GPS signals. Okay, so these are all the different types of signals which they want to use in the modernized segment, which will help them more powerful when compared to the other considerations. Now these are all the different countries. This is the US based GPS, Russian GPS, which is known as GLONASS, European GPS, which is known as Galileo, then Chinese GPS, which is known as Compass. So imagine, you must have seen the Russia and Ukraine war. These guys, in that case, Russia did not use GPS signals. They are completely used on GLONASS signals. Their missiles are based on GLONASS signals, not because of the GPS signals. Okay. Similarly, European Union, they also have developed this Galileo, and China. Why we say China is one of the most powerful country? Because they have their own independent navigation system. All their automobiles, all their missiles, they all work on compass chipsets, compass devices. So they have their own independent system, and they are not going to depend upon any other systems. Okay. Now, because the GPS signals are free to us, we are using them. But imagine if the US puts a sanction and does not release the signals to us, then imagine all our satellite launches are with respect to GPS time. All our, Ola, Uber, whatever we take is all with respect to positioning technologies. And all our electrical power grids are synchronized with respect to GPS time. All our cellular communications are again synchronized with respect to GPS time. So imagine a falsification of time, or there is no GPS, your whole country will get blocked. Okay? So therefore it is necessary to have alternative systems. You have to go for alternative systems, or you develop a multi-constellation system where your system will not depend upon not only GPS, but can also depend on GLONASS, Galileo, and other countries also. So in view of this, there are other segments which are there, which we will discuss in this one. So India has also come up with this particular system, that is known as Navigation with Indian Constellation. Earlier it is also known as Indian Regional Navigation Satellite System. Okay. Now this is the area which you have to focus on this, because you will find number of opportunities in development of the receivers, or in the scientific analysis or in the research analysis in this particular area. So this IRNSS is known as India's own GPS. We need not depend upon the GPS. We have launched our own satellites into the space and we call this as IRNSS. Now, why we want to go for our own GPS? Because GPS is already available. Why we have to invest? Why did ISRO invest in this one? Because during the Kargil war in the 1999, when there is a war between India and Pakistan, both people were using the missiles and both were depending upon GPS. But suddenly GPS signals were not available to India, but signals were available to the Pakistan region. So that was a surprise. Okay, GPS signals are free and they cover the whole globe. But they have a hidden technology that they will not cover only the Indian region, but rest of the world they can give it. So that feature we were not aware, but only during this Kargil war, that when that feature is implemented, many of our soldiers have died. At that time, India felt that we should not depend upon any other country's signals for position navigation. We should have our own GPS. So that is the reason. Realize the importance of indigenous navigation system. So with that, we want to become a self-reliant, and therefore the Indian government felt we should have our own system, which is known as Indian Regional Navigation System. Okay, so this is the EPS. So Indian Regional Navigation System, initially we want to develop it only to cover the Indian region, and this was completely implemented by ISRO, and this system will provide a position accuracy of around 10 meters over land mass and 20 meters over the oceans. Now this one was renamed as Navigation with Indian Constellation. Now across the world you will know as NAVEEN chipsets or NAVEEN system. In the mobile, in some of the mobile phones which I show you, already NAVEEN signals are available in those one. So we will call this as NAVEEN. Okay, so NAVEEN chipset. So 10 meters it will give you our Indian mass and 20 meters over Indian oceans. And this system will be able to provide you position, navigation and timing, 24/7 service availability under all weather conditions. So no more we will not use any of the countries, but we can rely completely on our own NAVEEN chipsets, okay, NAVEEN receivers. Like that of GPS, this also has got same architecture. You have the space segment, you have the control segment, you also have the user segment. Okay. Now in the space segment, now GPS has put the satellites in which orbit? In the medium Earth orbit at height of 20,000 kilometers. But we have kept our satellites in the geostationary and geosynchronous at a height of 36,000 kilometers, because they will be visible 24/7 to our Indian region, and you can use all this. So now in all our automobiles and all our mobile phones, we will have that is NAVEEN based chipsets, which can completely depend on it because it is our own system and we will use the 20. And Indian government has made a target that by the year 2025, all the mobile phones should have this NAVEEN receiver, otherwise they cannot be sold in India. Apart from that, in the RTA also they have introduced a rule that all the public vehicles, if they want to get registered for the licensing, they should have this NAVEEN receiver in these vehicles. And this NAVEEN receiver chipset will also be linked to the Aadhaar card, so that they want to track every person, every system, everything will be based on this particular NAVEEN mobile set. So they have kept a 1-year target to link all this, to find all the development of this particular receivers. And they are also encouraging different kinds of parties, vendors, different companies, startups to use this NAVEEN receiver, develop them, put it in every application. Okay. So we have put some satellites in the geosynchronous and some satellites in the geostationary, so that we will cover the complete globe. Okay. But GPS, because it is kept in the medium Earth orbit, there are 24 satellites are there, but we have launched only 7 satellites which will cover the Indian region. We are not going for global region in this particular case. Now these are the satellite names: IRS 1A, 1B, 1C, 1D, etc. Different satellites are being launched into the space using PSLV, etc. Recently NS-01, which was launched on 25th May using GSLV F12 flight, and this was successful. Now different satellites are there, which are launched for these Indian GPS systems, but one is failed to deploy, and the first one, because here the atomic clocks are imported, and this satellite is, it has got failed. this satellite will not be used for the navigation application, but this will be used for disaster management. Okay. There is a specific one satellite, IRNSS 1A satellite is used for disaster management. There they will send an emergency messages to each one of your mobile phone. Recently you must have seen that mobile phone, you must have received the messages in your regional language and other English language also. In case of earthquakes or in case of any tsunamis, this particular satellite will be used to alert your messages much before it's going to occur. Okay. So like this IRNS 1A satellite is used for disaster management application, whereas IRNS 1B etc. these satellites are used for position, navigation and timing applications. Okay. So like that we want to go for 11 satellites into the space, cover the whole Indian region, then we will go for the global system. Okay. Apart from that, the different ground segments, there are different, like that we are seeing in the ground segment, they are also having different ground segments. Now GPS will operate in L band, whereas our Indian NAVEEN system will operate in both L and S. Okay, L band is 1 to 2 gigahertz and S band is 2 to 4 gigahertz. Unlike GPS, we are going to operate in two different bands of frequencies, and we can develop a single frequency receiver or a dual frequency receiver set. Okay, so either of them we will be using the next slide. We will be able to use this particular segment. Next slide. Okay, now next. Like GPS, we are having two different types of services, SPS and PPS. We are also having the SPS and PS. Okay, this is for civilian application. This is also for our military applications. Now, when we launch the missiles or satellites, etc., we will not use GPS time, but we will use the NAVEEN time, and it is all based on, even our missiles are also based on the NAVEEN positioning services. Okay. So these are some of the satellite specifications, our NAVEEN satellite specifications. This is the first IRNS satellite which was designed and developed. Now, what are the applications? All our civil aviation applications, all the aircraft should have a NAVEEN receiver for aircraft landing and takeoff. That Government of India aviation sector will make it mandatory. And with this one, we will not depend upon any other foreign power for military navigation. Ultimately, we don't want to depend upon any other country for both civilian and navigation applications. So with this one, we will change it. So Government of India will have already started to make it mandatory that all our missiles or equipment etc. for military application should use only NAVEEN system. Similarly, all our civilian applications also should use this particular NAVEEN, and we will enforce in all the applications so that we are completely independent on that particular one. Okay. We also want to use it in cell phone for mapping, driving, biking, forestry applications, tracking the endangered animals, putting out wildfire, fleet management, taxi and truck company, monitoring drivers, disaster management, and during war also, naval fleet management, missile navigations. Everywhere you require all the systems should have NAVEEN. If you don't have NAVEEN, you cannot use it in the country. This is all the different kinds of applications. Okay. Now currently, when we compare them, the GPS has got 31 operational satellites. GLONASS has got more than this, and Galileo is around 30, and Compass around 50 and 30 bigger satellites. Okay. So all these are going to cover the globe, and this NAVEEN and Japanese QZSS. You see, you imagine Japan is a very small country, but still they have their own chipset. They have their own Indian GPS. They don't use GPS in their receivers, but they use only their Japanese GPS system. They are not depending on that. And even if you see in the Japan also, they won't find any. Most of the boards are written in Japanese only, not in the English. Okay, so that's another one. So with all this, what we did is we now the satellites have been placed in this space. So in the year 2016, we made an MOU with Space Application Center, ISRO, with our particular part, and we were part of the project in the development of these receivers, testing of the receivers, okay, especially in the testing of this particular navigation receivers. Now what is happening is satellites are launched in this space by ISRO, but who will tell that these receivers will be able to receive the satellite signals, will be able to give you the position. So okay, so across the world there are some of the places across the India, some places, some institutions were selected where these receivers are given to do the testing of these particular receivers. So accordingly, we have that receiver and we have this lab, and in this lab we have kept the initial NAVEEN receivers. Okay, so former ISRO chairman, he was there, and he was there to demonstrate, he was able to explain us the applications of these receivers. So initially we are having these bulk receivers, okay. So ISRO has given the, they had a MOU with the Accord Software Systems in the Bangalore, and they made this first NAVEEN receiver. Now this receiver can receive IRNSS, GPS and SBOS signals, and it can give you position application. This receiver will cost you around nearly 14 lakhs. Okay, it is an independent ISRO-based navigation receiver. Okay, here you get all the latitude, longitude, and other position applications will be given to you. And specific GUI is there where it will give you the position of the NAVEEN and also the signal strength of the NAVEEN with GPS. So you can do the comparative analysis of GPS and NAVEEN, both can be done. So you can see that such a bigger size is there in the initial stage. Now our task is to bring down into a small chipset, put that in the automobiles, put that in the mobile phones, then you will get this particular receiver chipset. So this was for initially this is a dual frequency IGS receiver. It's known as IGS receiver A296, which was used for do the analysis, testing of the signals, and then the collection of the data, and then we have to give back into the ISRO for the analysis. So this is a graphical user interface which will tell you the total number of satellites which are visible to our location. Okay. So if you put the tick mark here, you will receive the GPS signals. If you put tick mark here, you will get IRNSS, and this is for SBOS. And here you are getting latitude. So you can see how much precision you are going to get, latitude, longitude, altitude, the top values. And in this one, you are having the colors also, different colors for different satellites. And this one will give you that, the satellites which are in the elevation angle of some 30 degrees, satellites in the elevation angle of 60 degrees, like that. What is the elevation of the satellites and how many number of satellites are visible here. All this will be shown at this particular point here. This is another one, that is the company which is known as Data Patterns. It is an Indian-made organization. Again, they had a tie-up with the NAVEEN system, and they have developed this another module. It is a desktop-based module initially to test the signals. In the first phase, the satellite signal strength, the satellite visibility, constellation verification was done. Now, after the completion of this whole thing, you can now develop the receivers. Apart from that, what we did is we also had the our vehicle Innova, and on that one we have kept the antenna, NAVEEN antenna. Inside that we are having a receiver, and we traveled between the trees in the open sky, and we have done a lot of experimentation where we want to replace the GPS. Okay, already you are having a GPS here. In case if you receive a GPS with our NAVEEN chip, how does it is going to perform well? That experiment we have traveled in all our location. We have collected different scenarios. Open sky, then full under the heavy canopy, under the trees, and under the bridge we have traveled, and we have showed different kinds of results to them. Okay? And we've also compared the GPS and IRNSS in different areas and the locations. We traveled it and we have provided, and in fact we have already proved that this system is going to give you better positioning applications in the static and kinematic application when compared to the GPS. Okay, so that test we have already done it, and it was doing very well. Now, but what are the challenges? Issues are spoofing and jamming concerns are very important. Okay, so when we develop these technologies, when we develop the receivers, we also should have that receiver should be the best anti-spoofer and best anti-jamming technology should be incorporated in that one, so that your receiver can be used. You make only one chipset, put it in all the application, and you can manufacture them. That is the complete idea. Even aviation sector, they need a multi-constellation. Okay, not only with GPS, GLONASS, Galileo, they require n number of constellation. In case GPS is not available, go for GLONASS. In case GLONASS is not available, go for VIDO or then NAVEEN. Because aviation sector is very sensitive, you need to use that particular one. So interoperability means you can change from one constellation to another constellation. This is all it is available here. Okay. Now, as I said, GPS will give you the position accuracy of around 10 meters, but still you want more less than that 10 meters, okay? So, now we will go for a little bit next level of the thing. Now, if you see the aircraft, when it is landing, exactly it will, the tires of this will, move on this particular line. Okay, so that means imagine at that high speed, exact pinpoint position of this is very much required. Okay, now this is the scenario. Now this is the accuracy requirement for the different types of approaches. Okay, now aircraft was started descending. In case any issue on the ground, on the runway, then aircraft should have a capability to take off immediately. So in case the aircraft doesn't have capability to take off, in spite of the pilot seeing something on the ground, the aircraft will land and crash. Now, so therefore aircraft should have a different kind of setup. That is known as category 1, category 2 and category 3. So category 1 decision height is 200 feet. When the pilot started descending, at a height of 200 feet, if you find that it is not feasible to descend, then the aircraft can take off automatically. So that will come under category 1. Decision height is 200 feet and horizontal accuracy is 16.5, vertical accuracy is 3.4. And then decision height, category 2 is 100 feet. You still come down, you find something, then you can take off. That is horizontal accuracy 6.5, vertical accuracy 1.6. Decision height is 50 feet. You have come down much more down. Okay, but still you find it, you don't want to land it. So that height is around 50 feet, okay? So at a horizontal accuracy of 4.1 meters, vertical accuracy of 0.5, okay? Imagine 0.5 meters means very less. With such a high speed, the aircraft should take off. So this kind of facility should be available for the aircraft system. Now GPS will not support any of these three, okay? Now we are coming to the drawbacks of it. GPS does not support category 1, category 2 or category 3. Accuracy limitations of this particular precision approaches. Okay. Now in table 2 we have that GPS can provide you en route 2 nautical miles, terminal 1 nautical mile and approach 0.3 nautical miles. This is possible for the GPS, whereas you not able to meet this particular requirement. Okay. So standalone GPS is not adequate to support category 1. Precision approaches landing of these particular aircraft applications. And GPS cannot pass through the concrete structures and steel buildings. GPS cannot be used in indoor environment. Okay? But how we are going to get the position when you are using a mobile phone inside a building? Normally what will happen is the position will be taken care by the nearby base stations. The nearby base station position will be given to you and that's how you are going to get. But actual GPS system will not receive signals. It has to be in open sky. It has to have a direct signal. But here when you switch on here, you will not get any satellite signal here. So therefore GPS signals should have combination with any other technology so that they can provide you indoor applications. So since this GPS will not be able to provide a category 1, we have to augment the system. Augmentation means